Let's look at tutorial 2 question 4. Fresh orange juice contains 12 weight percent of solid and the balance is water. And the concentrated orange juice contains 42 weight percent of solid. Initially, a single evaporation process was used for the concentration, but volatile constituents of the juice escape with the water, leaving the concentrate with a flat taste. The current process overcomes this problem by bypassing the evaporator with a fraction of the fresh juice. The juice that enters the evaporator is concentrated to 58 weight percent solids, and the evaporator product stream is mixed with the bypassed fresh juice to achieve the desired final concentration. Calculate the amount of product, which contains 42% concentration, produced per kilogram of fresh juice fed to the process, and the fraction of the feed that bypasses the evaporator. First, let us draw out the process. So you have a bypass stream first, because the current process overcomes this problem by bypassing the evaporator with a fraction of the feed juice. Okay, so this will bypass the evaporator, means it will pass through the evaporator and not go into the evaporator directly. But some fraction will go into the evaporator to be concentrated. Then you have your evaporator, and then this is your mixer, the mixing stage. Okay, so we have a feed. It says 100 kilograms of fresh juice. We have a feed of 100 kg, and the feed contains 12 weight percent of solid. Let's use a blue pen. So this is 0.12, and the remaining would be 0.88. So since this is a bypass, meaning it's splitting a fraction of the fresh juice, so the concentration here and the concentration here will be the same, which is 0.12, 0.88, 0.12, 0.88. Up to here, the question here says the juice that enters the evaporator is concentrated to 58%, which is 0.58. So the remaining bottom here is 0.42. And our final product should have a 42% concentration, which is 0.42, and 0.58 for H2O. Now, since this is an evaporator, it only evaporates the water. Therefore, you have no solid over here, but the water here is 100%, which is 1. So you have 1, 2, 3, and 4, an overall process. You have 4 units over here. Therefore, we need to perform degree of freedom analysis for these 4 processes. So you have, let us go through 1 overall process. Okay, bypass, you have 1 process, evaporator, and a mixer. So you have a total of 4 processes. So for the overall process, we have 2 unknowns, which is M3 and M5. 2 balance, which is 1 total balance and 1 component balance. We have 2 components here, so we'll take 1 component balance. And the degree of freedom would be 0. Therefore, we should start by solving for the overall process first. For the bypass, we have 2 unknowns. Bypass is over here, which is M1 and M2. And 1 balance, because it is a splitter, so the concentration is the same. Therefore, your degree of freedom analysis would give you 1. For the evaporator, we have three unknowns, which is M1, M3, and M4. And we also have two balance, which is a one total material balance and one component balance, leaving us with a degree of freedom 1. And the mixing point here, we have three unknowns. We have M2 here, M4, and M5. We also have two balance, same like the one before, and our degree of freedom is 1. Therefore, we should start with solving for the overall process first, because the degree of freedom is 0. Now, for the overall material balance, the total balance is F should equal to M3 plus M5. And F is 100, M3 is, what is M3 here? Okay, we don't know what's M3, plus M5. We can then do component balance for the solid as material balance, which is XS F multiplied by F should equal to 0. X S at 5 at M5. So this one is 0.12. Your feet is 100. We have this, which is 0.42, and we have an M5. So we can substitute M5 into the equation. We can solve for M5. Okay, so M5 should be 28.6 kilogram. Then we substitute M5 back here, and we can solve for our M3, which is 71.4 kg. Sorry for the previously. So the question actually wants us to calculate the amount of product produced per 100 kilo of fresh juice fed through the process and the fraction of the feed that bypasses the evaporator. Basically, it wants us to find M5 and it wants us to find M2 over F. Okay, so then we need to find M2. After this, we can perform we can solve for the mixing point. For the overall, so for the mixing point, it is M4 plus M2 should equal to M5. M4 plus M2 should equal to M5. So we have M5, but we don't have M4. Okay, then we can do the material balance for the solid, SMB, material balance, and that is XS4 times M4 plus XS2 times M2 should equal to XS5 times M5. So we don't have M4, we don't have M2. But we know that XS5 is 0.42. M5 we have found, which was 28.6 kg. XS4, 0.58. XS2 is 0.12. So we can solve this simultaneously. This one is 28.6. By solving it simultaneously, we should get M2 to be 9.95 kg and M4 to be 18.65 kg. Okay. To solve for M1, we can use the bypass section and do overall material balance. So F should equal to M1 plus M2. F is 100, M1 we don't know, M2 we have solved, which was 9.95 kg. Therefore M1 is 90.05 kg. Okay, so the question wants us to find the bypass fraction. Therefore, the bypass fraction is M2 over F, which is 9.95 kg over 100 kg, 0.0995.